Okay, I will continue as I told you on the cross multiplication. The cross multiplication is very, very simple. All I have to do, if you multiply two vectors, cross multiplication, I will do this way. I will write ijk. What's ijk? Do you remember? Which is E1,
Yeah.
E2, and E3. Am I right? So this is 1 double 0. This is I. 1 double 0. This is 0, 1, and 0. This is 0, 0, 1. So, but in multiplying cross multiplication, I will get the perpendicular vector on two vectors. So mainly, if I have two vectors, V1 and V2, once you multiply them, cross multiplication, you will get the perpendicular vector on both of them. That's a huge advantage, actually. Okay? So simply, I will get I, eliminating the first row and first column, I will have a determinant which is 2 by 2, as you can see, minus J, I will eliminate the row and column, I will have A1, A3, B1, B3. Similar manner for the third element. So actually, the dot multiplication will give you a number. If I have A dot V, the dot multiplication or the inner multiplication, it will be a number. But in cross multiplication, you will have a vector, which is perpendicular on both of them. Okay? Okay, once more, the result is an orthogonal vector on both of these two vectors. For example, Miss Nada or Miss Fatima. لا كده غلط. I have vector 2, negative 1, and 6. I have the second vector, which is negative 3, 5, and 1. I need a perpendicular vector on both of them. All I have to do is to make a cross multiplication. That's the cross multiplication, A cross B, ijk. This is vector 2, negative 1, and 6, negative 3, 5, and 1. Try to evaluate, معايا Ms. Jana, both of them, all of these values. This is gonna be the value of the perpendicular vector, which is negative 31i, negative 20j, 7k. Remark, if you multiply the elements, negative 31, negative 20, and 7 in the first vector, the result will be 0. If you multiply dot product, I mean. And if you multiply this vector by negative 3, 5, and 1, also the result will be 0, which means this vector is perpendicular, orthogonal, on both of these two vectors. That's the huge advantage of using cross multiplication. Note the resulting vector AB orthogonal to both A and B, as I told you. And also, this could be proved easily by getting after cross multiplication, like exactly what I did. Times A or A cross B times B, the results will be zeros. Also, I have the positive direction. If you are multiplying from A to B according to the right hand rule, you will have the positive direction for the multiplication of these two vectors. So, if you work with the right hand side, you will have the positive direction, which means a positive. So geometric interpretation means the resulting vector of A V is perpendicular on both planes, on both vectors in A and B. The definition, cross of the scalar, let B be a basis of R3, where B is the matrix of the ID transform from B into the standard basis of R3. So I will have positively oriented in the case of the right hand side and the negatively oriented. This can be controlled by evaluating the determinant of this matrix. If the value of the determinant is greater than 0, then you will have positively oriented. If the determinant of this matrix is less than 0, then you will have negatively oriented matrix. So the standard basis for R3 is 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, as you already know. Oriented because IDE from this this basis into this basis will result I3, and the I3 determinant is positive 1, which is greater than 1, so it's already positively, as I told you, positively oriented. Let B a positively oriented basis for R3. Note that B dash for R3 is also positively oriented if the determinant is greater than 0, and it's exactly like the definition, so there is no more information added in this part. If U and V are linearly independent vector of R3 and the lambda is a positive real number, then there is exactly one vector Z of R3 such that that vector z, which is the result of the cross multiplication of u and v. Okay? So if you have z and u are orthogonal, also z and v will be orthogonal. Okay. Also, the magnitude of z will equal to lambda. Also, u, v, and z is a positively oriented basis of R3, since you are getting z from the cross multiplication of u and v. Under the assumption of the above proposition, we still have u doesn't equal to the origin, and the v doesn't equal to the origin. So the angle between u and v, it will be between 0 and pi, and they will be given by this relation. This relation connects the cross multiplication. Remember, you have a relation connecting an angle between two vectors in dot multiplication. Do you still remember it? Cosine alpha is equal to the inner product of u and v divided by the magnitude of each one of them. But in the cross multiplication, the magnitude of the vector will equal to absolute u, absolute v times sine the angle between them. I will get it to you just in a second. Here we go. Okay? Here, if u and v are vectors in R3, then the cross product of u and v denoted by u cross v or u or v is the vector of R3 defined as follows. U or v are linearly dependent, while u cross v is equal to 0. So for any two vectors which are linearly dependent, their cross multiplication is equal to 0. Farid, it's complete logic. Because if you have two vectors linearly independent, that means one of them will be generated from the other. It's like 1, 1, 1, 2, 2, 2. Those are linearly dependent vectors. So if you try to make a cross multiplication, you will put them in a determinant. Am I right? So the first vector is going to be a, and the second vector will be 1, 1, 1. Exactly the same. And do you know, if you have two vectors alike, if you have two rows alike in a determinant, the value of this determinant will be 0. So it makes sense. So number one, if u and v are linearly dependent, then u cross v will be 0. And the second remark, if u or v are linearly independent, then you will have a perpendicular vector. Okay? Then u cross v and u are orthogonal, or u cross v and v are orthogonal. It's orthogonal both of them. Okay. The magnitude of the cross product vector is equal to the magnitude of u times magnitude of v sine the angle between both of them. uv and the cross multiplication is a positively oriented basis for R3. So if I have two vectors, they are linearly independent, and they make a cross multiplication, I will get the third one. The third vector is gonna, with them, it's gonna be a basis for R3. So, ya shabab, if I have W1 and the W2, do you remember the problem that we were solving with 3 times? Okay, if I have the equation, which is x, y, and z, x minus 2y plus 3z equal to 0, so I can get the basis of this matrix. I can get the basis of this subvector space, which was 2 vectors. If you cross multiply these 2 vectors, if you cross multiply them, you will get the third. And it's gonna be a basis for R3. And also, you can use this basis for R3 to get the coordinates controlling the vector. And by knowing this, you can get the projection of the vector on the subvector space and on the other on the orthogonal component. Okay, it's really helpful. I'm sorry. I mean the cross multiplication. E1, E2, E3, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. They are number 1 orthogonal. So if you multiply 1, 0, 0, 1, 0, 0 times 0, 1, 0 cross multiplication, you will get the third. And this is written in here. So this was so normal basis for R3. So E1 cross E2 will give you E3. E1 cross E3 will give you E2, and so on. Okay, once more. And the E3 is equal to the magnitude of E3, for example. It will be the magnitude of E1, E2 sine the angle between both of them, and so on. Okay? So E1, E2 is 3B, absolutely oriented orthonormal basis for R3 if U can be expressed, as I told you, from a basis on E1, and the V, it's also another vector, is a linear combination. If you got these vectors multiplied, this is the I, that's the J, that's the K, which is once more the cross multiplication definition. Finally, it's positively oriented. This is ijk as I told you, and this is coordinates of first vector and coordinates of second vector if you multiply them together. Now, also I have these remarks. U cross V is equal to the negative of V plus cross U. Miss Fatin.
Yes.
If this makes sense? ليه؟ ليه؟ هي فعلا بديهية جدا. ليه بقى؟
ليه؟ عشان you change the order.
عشان انت change 2 rows in the determinant. Once you change 2 rows, okay, reposition 2 rows, the sign will be negative. Okay. طيب, lambda U cross V, it will be equal to the same. If you can distribute the addition of 2 vectors on the cross multiplication. Also, you can distribute the cross multiplication on the addition of 2 vectors. Okay, U cross V cross W is not gonna equal to U cross V cross W. Okay, they're not gonna equal to each other in general. Okay, for instance, E1, E2, E3 is a positively oriented orthogonal basis for R3. Then E1 times cross E1 cross E2 is equal to 0 times E2, which is 0. While you try it once more in another arrangement, it's going to equal to negative E2. This is why this relation is not correct. I'm trying just to go just a little bit. If you mix, this is almost the last slide. If you mix the cross multiplication or the dot multiplication, the result will be a number. Because the cross multiplication will give you a vector. But the dot multiplication of vectors will give you a number. I can do it all together, making the cross multiplication and the result times another vector. So this is called a triple multiplication. بصي, scalar, this is called the scalar triple multiplication, which is U cross V dot W. Already it's very, very simple. U cross V is a vector. This vector will be multiplied in W. By the way, I can do it all together in this matrix. So if I have U alpha 1, alpha 2, alpha 3, V beta 1, beta 2, beta 3, and the W gamma 1, gamma 2, gamma 3. فريد, تعرف في E1 و E2 و E3؟ ده الستاندرد بيزس 1 0 0 0 1 0 0 0 1. يعني ده فيكتور 4 5 6, ده فيكتور 5 6 7, ده فيكتور whatever it is. I can get U cross V dot W by putting them all in the matrix by this form. I can get the result. I can get the number. راكوا فاهميني؟ مش واضح انكم فاهمين. فاهماني؟ Mr. Zaid, okay? Okay, these are the relations of the triple of the cross triple multiplication. U cross V W, it's gonna equal to minus U cross W dot V. You will have to memorize these 5 relations. He can ask you about them in the exam for the true or false statements. Okay? And by the end of this slide, we now ended chapter 7. I'm going to chapter 8 next time. It's really very simple, and please try to attend. It's gonna be on Thursday, inshallah. On Thursday, I will try in 1 second to finish chapter 8. It's very simple. Okay? It's just an application on all the knowledge that we have previously. So it's really very simple. How to formulate an equation of a plan, how to formulate an equation of a straight line, what's the relation between straight lines in space, what's the relations between planes in space, and by the idea. This part we also teach it in all of the engineering schools in Egypt. Okay? For this chapter, which is chapter 8, the straight line and the plan. It's really very important. Okay? I will go through it next lecture, inshallah. Thank you very much. Thank you, Ms. Faith.